All right, thank you, Shannon, and good evening, everyone, or good afternoon, depending on what part of the world you're joining us from. As Shannon mentioned, my name is Sam Nasr, and this is going to be an introduction to artificial intelligence. A little bit about me. I've been a software developer since 1995. You can also find me on Twitter with the handle @SamNasr. I am the senior software engineer as well as instructor for NIS Technologies. I've been certified with a few certifications from Microsoft. And one of my biggest enjoyments is running the Cleveland C# VB.NET User Group, as well as the .NET Study Group, which also meets online. I've also authored articles for Visual Studio Magazine and Twilio, and I've been a 5-time Microsoft MVP and actually just recently received my 6th MVP award. And a shameless plug, if I may, for the Cleveland C# VB.NET User Group. We meet every month. The meetings are free of charge and open to the public, and we cover a variety of topics related to .NET. And like all other user groups, you can find the meeting information posted at meetup.com. And so with that, let's jump into tonight's agenda. Basically, my plan is to do an overview of the differences between AI and machine learning and take a closer look at the building blocks thereof. Then we're going to look at Azure Cognitive Services, and of course, everyone's favorite, ChatGPT. And depending if time allows, we'll look at AI with T-SQL. So let's dive into the overview. And for many of you, it probably seems like alphabet soup with the terminology interchanges between artificial intelligence and machine learning. And then you got things like deep learning and neural networks. So my hope tonight is to help iron all that out and be able to help you identify what is what and be able to differentiate between the two. And so starting from the bottom layer, you have the neural networks, and we'll talk about those in more detail, but that is essentially the building block for deep learning. And with deep learning, essentially, if we have more than 3 neural networks, then we have what's called a deep learning entity. From there, we can build upon that, and then we can have machine learning, which is a subset of AI. And as you see in that diagram, everything is nested together with neural networks being the building blocks. So we can start with a basic neural network. We can add more than 3 layers to it, and now we have a deep learning entity. And then we can expand on that by using machine learning, which it comes in a couple of variety flavors, primarily supervised and unsupervised learning. So that means that we can, with supervised learning, we can give it, and as you'll see in the demo, we'll have 2 columns of data. One is the one that we want it to learn on, and the other is the one that we want it to predict on. So think of it, best example I can give you, we've all interacted with a 3-year-old upon one point or another, right? You always tell them, you know, this is a nice thing to say, this is not a nice thing to say. And so that's essentially machine learning at its basic fundamental step. And we'll be walking through that in a demo in just a little bit. Once we've taught our machine, or once we've created our own model or a transform, then we can use that for making decisions like a human would. And that's where artificial intelligence comes into play. So let's dive a little bit deeper and start with neural networks. And what you see here is a diagram of neural networks where basically we have the input layer on the left, and then we have the output layer on the far right. And then in between, we have more than 1 layer depending on the decisions that we need to make. And think of neural networks kind of like a decision tree. You're providing one input, and then based on the output of that, you're going to make another decision. So for example, a very basic example would be, I'm hungry. Do I call for pizza? Well, that depends. Is the wait time going to be longer than 40 minutes? Then no, I'll just go to McDonald's and order a burger. And then if I go to McDonald's, how long is the wait in the drive-thru? If it's longer than 5 minutes, maybe I'll abort that and go somewhere else. So there are various decisions that I am maneuvering through based upon as data is exposed to me. So that essentially, in a nutshell, is what a neural network is. You have multiple layers. Think of it like a decision tree. And each circle that we see here is essentially a node. And so think of these individual nodes as models where it's composed of input data and we have weights on them. And then once we assign these weights, then we can move forward. And let me give you a better example. So think of this as a neural network. So we have 3 pieces of input up at the very top. And this is for an example of someone that wants to go surfing. So he would ask, are the waves good? That's number 1. Is there a large queue of people that are waiting, or is the beach crowded? That's question number 2. And question number 3, has there been a recent shark attack? And so we're going to assign either a yes or a no to these values. And we're going to give them numeric values, but then we're going to give them weights, meaning how heavy is each answer going to be weighed. So for example, assuming that I'm a great surfer, are there large swells in the surf? If so, that's heavily weighed in comparison to the other options. The second one, is it crowded? That really isn't going to matter a whole lot to me, so I'll just give it a weight of 2. And then the last one is the fear of sharks. Obviously, I'm not a big friend of sharks, and so I want to avoid that, and so I'm going to give that a 4. And then we'll, for the sake of argument, we'll assume that we have a threshold value of 3, where once my weighted values exceed 3, then I know it's okay for me to go into the water, given all these factors. And so that essentially is building my neural network for the decision-making of whether I'm going to go surfing or not. By the way, I heard some microphone static. Did someone want to jump in with a question? Okay. I should also mention, feel free to jump in at any point in time with a question. Don't necessarily wait for the Q&A period, but I always welcome questions and comments as we're proceeding. And so with that, getting back where we had left off, so looking at my neural network example, let's assume that the waves are good, so I'll give that a 1. The line is empty, there aren't many people. There are plenty of people, so I will give that a 0 for the line being empty. And has there been a recent shark attack? I will give that a no, which will be assigned a value 1. Taking all that into consideration, I plug it into the formula at the bottom, where I'm using the weights that were assigned to each portion. And now I have a 6, which is a positive value. Now I can go surfing. So taking that into consideration and comparison with what we were talking about with each individual input layer, and then there's a decision that's derived from that, that will help me identify whether I'm going to go surfing or not. So going to the basic diagram that we saw earlier, the neural network is the very core of all the decision making that we build on and get to the point of artificial intelligence. So with machine learning, there are many frameworks that are available. I myself drank the Microsoft punch, and so I've been focusing mostly on that stack. And so like all the other frameworks that are available, there is a ML.NET or machine learning.NET framework that's available from Microsoft. And we'll step through a demo and show you how to work with that. But before we do, just wanted to cover some terminology. So first, what we call a feature in machine learning, that's essentially the input value. So we're giving it a value, whether it's a size or mileage of a car or the square footage of a home. And then we get a label out of it, which is the output value. So these are the values that were used to train the model, i.e. the output price. And then in between, what we're doing is we're building a transform or a type of prediction. So we give it a feature, we identify the label of what the output should be, and then it automatically will develop that transform or the formula in between. So that way, when we give it another value for a prediction, it can give us the expected output. So think of home prices, for example. And we all know that home prices, they fluctuate depending on the zip code that you're in, the number of bedrooms, the square footage, condition of the home, et cetera, et cetera. But let me break it down into a very simplistic example. Let's assume that home prices were based solely on square footage. And let's assume that 1,000 square foot home is 100,000. A 2,000 square foot home is 200,000. So naturally, if you were to predict what's the value of a 3,000 square foot home, you would probably say 300,000, right? It's a linear regression. And so I'm giving you the feature, which is the square footage of the home. You're giving me the label or the output value. And then because I gave you a series of data, in this case, it was only 2 items of data or 2 records, you were able to develop a transform or a formula to be able to calculate that output value. Is everyone with me so far?
Yes, we are.
Excellent, very good. All right, thank you for the feedback. So having said that, with machinelearning.net, we can develop a variety of different types of predictions. So we can use classification, meaning define whether something is good or bad. We can do linear regression as we did with the home prices. We can also utilize it for anomaly detection to see if something is out of the norm, i.e. credit card spending, for example. If I buy $200 of gas every month, and all of a sudden I'm buying $800 worth of gas, obviously that's an anomaly, something spiked there. I can also use it for making recommendations. We all came across a website called Amazon.com, where every time you buy something on there, it also makes a recommendation of, well, how about this to go along with it? Let's say I purchase a cell phone case, then it will also recommend a screen protector for me, right? And we've all got suckered into it, you know, after you hit the buy button, yeah, this actually looks good, I'll buy this one too. So it can make those recommendations. In addition, we can look for time series sequential data, so we can use it for sales and forecasting long-term. And last but not least, we can use it for image classification, meaning I produce an image and it will classify it as a fruit or a vegetable. I can also help to identify whether it's part A or part B within a diagram, an exploded diagram of a working machine. So there's a variety of things that I can use it for in these prediction types. Now, having said that, what is the process that I go about developing my model or that transform? It's really a cyclical process, and it starts by first and foremost collecting and loading the data. And then we create a pipeline where we start to feed that data into it. And then we train the model where it's actually reading the data and then processing it. So it's looking at the features, and then it's looking at the labels, and it's learning how to develop a formula to be able to get from a label, to be able to get from a feature to a label, to get from an input to an output. Then after I'm done training my model, the next thing to do is to evaluate it. And then if I'm satisfied with the results, then I can just simply save the model as we see on the bottom of the screen. And then I can start using that in my application. If, however, I evaluate it and I'm not satisfied, the cyclical process continues again, where I load more data, append it to the pipeline, train it, and then reevaluate it until I get to a satisfactory evaluation or prediction. So if I get to a point where I'm happy with the model, now I can save it and use it in a project. And to do that, basically, I would load it as I would any other library in my code. And then I would use the load method, and then I would make a call to the prediction engine, and specifically the predict method. And this is solely within the ML.NET framework. So these are all function calls within the ML.NET library, but the entire process, as far as being cyclical and testing and training the data, that is essentially universal for developing a model. So looking specifically within the .NET environment and for building a machine learning model, the first thing that I need to do is I need to install the desktop environment, and then I need to select the ML.NET model builder, as you see circled over on the right. Once I have that as my prerequisite, now I can start to add in a machine learning project, and I can do that in 3 different ways. I can included through the UI by right-clicking on the project and selecting Add. And there you see machine learning as the object that's identified in the context menu. Another way I can do it is programmatically by including the Microsoft.ml NuGet package. And then, like everything else in Microsoft, I can also do it using the command line interface. And so with that, let me pause once again and see if there's any questions so far before we get into a demo. All right, so let's jump into a demo. It's always the best way to explain things. And so what I have here is basically, I'm starting a new project template. Let me share that here. And I'm going to create a console application. I'm going to do it within Windows. And let's go ahead and start that up. And let's call it ML demo. And click next. So this is going to create a very basic console application. We'll give it a second to chug and create the template. And as you can see, it's taking a New York minute to get through this. And there it is. So very bare bones console application. All it's doing is just has the basic hello world line in there. I didn't do anything else to it. So what I'm going to do is I'm going to right click on the solution, and I'm going to select Add, and then let me try that again. So I right click on the project and I click Add, and there is my machine learning model. I'll go ahead and select that. And it's going to give me the default name of mlmodel1.mbconfig. I'll go ahead and accept that. Now it's going to walk me through a user interface for selecting what type of prediction that I need to make. And as if you recall from the previous slide, we said there are multiple different prediction types, whether it's image classification, recommendation. We're going to go ahead and utilize data classification. And what this does is it's going to categorize data in one of two categories. And we're going to be looking at a file that contains comments that were downloaded from Yelp regarding a pizza place. Let me backtrack again. So these are the different scenarios that we can select from on how to train our data. And if you'll notice, many of them can run locally, but some will allow me to run it in Azure. So that way, specifically with image classification, that is a resource-intensive process. And so therefore, instead of hogging up my machine, I can point it to Azure and it can utilize the computing capabilities of Azure. Likewise, the same thing with object detection. I can run it in Azure. Data classification, on the other hand, not so resource intensive. So that's going to be running locally. Now it's giving me an overview of my local CPU environment. We'll go ahead and click next. Now it's time to select my data. I am going to be getting the data from a file as opposed to the other option, which is SQL Server. Let me browse down to here. And this is the help data that I was referring to. So let's take a look at that file. So this is a tab delimited file where it contains two columns, essentially the comment itself, and then a 1 or a 0 indicating whether this comment was positive or negative. So I want to do sentiment analysis on this data that I'm given. And so let me go ahead and select that file. Now it's loading that file, and it's going to ask me what is the column that I want to predict on, i.e. the label. That's the output. So I'm going to select the second column. And as you see here, I got column 0, that's my feature. And then column 1 is the output results. And so I will select the next step. Now it's giving me a prompt for how long should I train it. I'm going to accept the default of 10 seconds. And we'll start training here. Now, what's going to be happening, as you'll see in the output window on the bottom, it's going to run through a variety of different algorithms as it's training on the data. So it's looking at the comments, and it's looking at the output value, and it's looking to see, and apparently I have an error. Interesting. Let's try that again. Not sure what caused that. Okay, so as you see with the time allotted, it went through and it explored one model, i.e. one way of how the data was transformed. We can wait until it's done finalizing. Once it's done, this next step button will be enabled. Now you'll notice that I only gave it 10 seconds as default, right? But it's telling me the accuracy is going to be 49% or 0.4917. And I apologize for the delay. This is the first time it's been delayed like this. Usually runs much faster, but you know how it goes with the demo gods, right? All right, there we go. So now my next step is to evaluate it, and I'm going to pass in the statement, crust is not good. And I'll wait once I click the predict, then it will produce the result over on the right-hand side. And because of the time that I gave it, it wasn't sufficient enough. And you see the accuracy, 49%. So it's a mixed result of 50-50. So I'm not satisfied with the results. So I can go back and I can retrain it again. Let's go for 20 seconds and we'll train again.
Hey, Sam, I have a question.
Sure.
You're using Visual Studio, which I know is a pretty powerful IDE. Have you done any of this with just VS Code? And how
I
much more
personally have
difficult
not.
is that? Okay.
But you certainly could. Like I said, there's multiple ways of creating the project. One of them is through the command line interface. And so you could utilize VS Code for that. I personally am a big fan of Visual Studio because you have the entire tool set, very rich experience. So I'm a big fan of it. So as you see here, I ran it for 20 seconds. My accuracy increased to 72.5%. It ran through two different algorithms, and they are listed on the bottom here. And so now I should be able to get a better prediction. When I say crust is not good, it should come back with a negative result. Oh, all right, let's try another example. What if I say, don't bother coming here? All right, let's try a third one. Okay, so this has not happened before, believe it or not. I've always ended up with results that were 99% confidence or 98% confidence. So this is a first. But for the sake of time, let's assume that I'm satisfied with the results here, and I can move on to the next step. Now I have my model. I am able to use it in an application, and it's giving me multiple ways to utilize that in my solution. I can either use it by cutting and pasting this code snippet. I can add it in as another project in my solution, as another console application, or I can use it as a web API to call into it. And last but not least, I can use it in an interactive notebook. So I'm going to opt for the adding it to a solution as a console application. It gives me the default name. I'll add that to the solution. And there you see, I now have two projects. I have the ML demo, which is the basic project that I started off with. And then I have the ML Model 1 console app that I added on after I built my model. And so looking at that, what you'd also notice is that I also have an ML Model 1.zip. That is the machine learning model that I developed in the first project by going through the click interface. I have my model. It now saved it as a .zip and incorporated it into my new console project. And then when I look at the program CS of my second project for using that, basically it's pre-populating the data or it's pre-populating a prediction where it says crust is not good. And then it's going to take this sample data and is going to pass it into the prediction engine. And then that will give me the result back. And so let me go ahead and run through this. So we'll put a breakpoint here and run this. And right now it's launching another console application. So it's building the entire solution. And I should see a command window pop up or a console window. And let me bring this to the foreground. All right, so there's my breakpoint. So what it's doing here is instantiating the model that I incorporated in this .zip. It's instantiating that, and it's setting the data to predict into the string. Then we're going to take that string that's incorporated in the sample data object, pass that into the predict method, and then we'll get a prediction result out of that. And so we'll step through that. And as you see in my output, basically it says crust is not good. And the result that came back was that it's negative. And it's showing me the predicted column was, or the result that came back from the prediction is also negative. So what I did was, again, in a nutshell, I gave it data. And let me open up that file again. So this is the file that I'm referring to. This has all the negative, all the comments and whether the comment was positive or negative. I trained it on all these records for 20 seconds. And then it was able to, I passed it in a phrase, crust is not good. And it was able to produce the results saying that it was a negative comment. So I can also say, I can try to enter in something at random and say, don't bother eating here. So now it's spinning up another window. We'll go ahead and hit continue and run to completion. Let's try that again. All right, so even though I put in the data, don't bother eating here, I forgot to update this sentence as well. But essentially the prediction that appears down here says that this is a negative comment where the predicted value is 0. So I trained it on a variety of different phrases. I gave it something that was not included in that list, and it was able to make a smart prediction. Hence, think of the 3-year-old example. You train them on good phrases and bad phrases, and then later on, when you expose them to a new phrase, they're smart enough to say, oh, this is a bad phrase. And so that's what we did here. Okay. Let me pause and see if there's any questions.
Yes, this might be a obvious question, but the ones and zeros, did you manually put those in for training, or did you find another method to put them in?
So I cheated and I downloaded this file, but essentially it was, this is what's called supervised learning, where I am identifying what's good and what's bad.
Okay, so you make that prediction yourself and then you train it, or
Right.
you make that judgment yourself and then you train it based on that data.
Correct.
Okay.
And so after I'm done training it, then I introduced a new phrase that wasn't in there, which is don't bother eating here. And then it automatically calculated that this was a negative comment. Make sense?
Yes.
Okay, very good. All right, so where we're at right now is that we built on the neural networks. And let me share my slide deck again. So we started off by talking about neural networks and how it acts like a decision tree. And then we can build on that by adding in additional layers and making it deep learning, meaning there's multiple decisions that are happening on the back end. And then we're able to get to a level where there's machine learning or supervised learning in this case, because we're labeling the comments that I gave it and providing a label, whether it's good or bad. And so we are now up to this orange level. And if you notice, I did nothing with neural networks or the deep learning. That was already built into the framework, but that's how we got into the machine learning aspect of it. So we utilize the building blocks that's within the SDK of ML.NET, and we're able to provide the data. And then from that, we were able to build a model or a transform, and then we could use it to make predictions. So right now we're up to the orange level for machine learning. And so the next thing to do is we want a couple more slides to go through. So the time to train it, as you saw, I ran into a little bit of an issue where when I provided it with 10 seconds, it didn't give me the results that I wanted. And so I upped it to 20 seconds. That was the cyclical process that I was referring to earlier, where I provided the data, I train it, and I evaluate it. If I'm not satisfied, continue again. And so within 10 seconds, I was only able to cover so many records and so many algorithms, but more time equated to better performance. And speaking of performance, like I said, more data, but more importantly, something that I didn't mention up until now is you want clean, meaningful data. So obviously for demo purposes, this data was already scrubbed and it was cleaned. But going back into the example that I mentioned earlier, if we were doing this with housing data, we don't want to just provide square footage and the price alone, but rather we want to give it context. So things like the number of bedrooms, the condition of the home, the age, all these are features that go along with the context. So for example, if you were to ask a real estate agent, how much is a 3,000 square foot home? His answer would probably be, it depends. How many bedrooms? Where's it at? What other amenities does it have? All that goes into the context of the price. Another way to improve performance is cross-validation, which is a model evaluation technique where you can break the data into several partitions, train it on that, and then evaluate the results. And then if you notice, as I was running it through with more time, it went through different algorithms, and that's how I can evaluate the performance of it. When you run it through different algorithms, it automatically comes back with, or it chooses the best results, and it comes back and it improves the results or the accuracy of the results on the return. So giving it more time, running through different algorithms will help to improve the performance. The scenarios, we already covered that, and a couple gotchas. So 32-bit is supported on Windows, except if you're using it for TensorFlow or LightGBM and ONNX related functionality. So those TensorFlow, LightGBM, and ONNX, those are different machine learning frameworks, which you may encounter an error if you're running it on 32-bit. Also, another issue I had is, although it supports 64-bit, you need to ensure that your application is targeting 64-bit. Otherwise, sometimes it'll veer off and process on x86. So the solution for that is, for the project setting, go to build and then set the platform target to 64 bits. And the new project created by the UI sometimes may have a different version. So if you noticed, after I was done building my model, I said, add this to the solution as another console application. With the previous version of Visual Studio, it always added it in under a different version of .NET. Luckily, it's fixed in 2022. So that does it with the machine learning. Any questions before we move on to AI? And again, my intent here was to just simply walk you through the building blocks and see how you can utilize various AI features, but essentially everything builds on the machine learning, which builds on the neural networks. So let's step into the AI realm. Being a big Microsoft fan that I am, one of the things I'd like to introduce you to is Cognitive Services. It's a set of services within Azure that provide human interpretation. So essentially, they've taken the neural networks, they've built on them, added machine learning, did some importing and training of the data, and now we have applications or services that can essentially do interpretation as a human being would. So these services, they're essentially used for building intelligent applications that can literally see, hear, speak, and understand in a similar manner as a human would. So you can use these as direct AI. Direct AI or data science skills are not required, but rather the nice thing is all these technical and mathematical details have been abstracted, and the services are provided where you can, once you set them up, you now have access to start using them within Azure. And as you had seen, although I went through the manual process of building the model and evaluating it, this was already done within the Azure Services. So everything is pre-built and ready for use. So these models, depending on which one you're using, whether it's, we'll talk about Lewis in just a second, that required an external portal that was linked to Azure in order for me to further train it on some specific phrases. And so essentially I access the portal and I can access it using the APIs and the SDKs that are available via Azure. So the set of services, they're divided into 5 different categories. You have vision, decision-making, language and speech, and then everybody's favorite, OpenAI, which involves ChatGPT. And so let's dive into it in a little bit more detail. And more specifically, let's look at the Lewis demo. And so, as I mentioned earlier, everything is available within the Azure portal. And if we open that up, so here's my Azure portal. I already have it logged in, and you'll notice that I have some resources that are available that I already created. One of them being the language understanding. And so within this language understanding, essentially, I'm provided with keys and endpoints, and you'll notice the keys are blocked out because that's essentially my secret or private key that I'm using to access my account and be able to access the portal or be able to access the language understanding service. To get to this point, let me backtrack and go back to my home screen. So everything that I use in Azure will involve a resource. And so for starters, I'll select create a resource. And it's giving me a variety of items to choose from. I'm just going to type in language service. Then I would select this one for creating the language understanding rather. And I will go ahead and create that one. Now it's going to prompt me for the authoring resource and the name of what I want to call it. Now, it's giving me a little notice here saying that Lewis, or Language Intelligent Understanding Service, is being retired on October 1st, 2025. Not a problem here because I've already created it, but if you were to either create a new one, you can migrate it over into the new language understanding service, or excuse me, natural language understanding service, which is now available through Microsoft. So my point is, I had to create a resource in order to utilize Lewis. So if I go back to my home screen, this is the resource that I created. And once that was done, now I can go into the Lewis AI portal, which is tied with Azure. And what this allows me to do is to be able to access my application. So with natural language understanding, basically, it's just as the name suggests. It takes natural spoken language, just like I'm speaking to you, and it's able to decipher the intent. So I built a demo here that revolves around a kiosk at a car dealership. So some of the things you would do at a car dealership, obviously buy a car, maybe trade in your car, maybe get your car serviced. So there are different intents of what a user would want to do at that kiosk. How they phrase it could be different from one person to the other. I could say, sell me a car. I want to purchase a new vehicle. Do you have a car that I can buy? All three are 3 different sentence structures or 3 different utterances. And so I would log into this portal, set it up on the different intents, and I would train it. So for example, one intent is for a user to buy a car. So if I click on this intent for buy car, what I did was I set it up with 3 different phrases or utterances. I'm looking to get a new Explorer. I'm interested in buying a Mustang, and I want to buy a car. And if you notice, Explorer, Mustang, and car are all labeled as the entity of car, because every sentence structure contains a verb and a noun, right? And so here I'm defining what my noun is, and I'm defining what my intent is. So my intent is this token buy car. So anytime a user says anything remotely close to any of these phrases, I will automatically respond back and say, oh, the user now wants to buy a car. Everyone with me so far? Can I get a virtual head nod or a thumbs up?
Yes.
Yes.
Excellent, thank you. Okay, so I've set it up with 3 different utterances here. And as you see, I trained it, and you'll see that it's giving me a confidence score of 93% and 89.5% on the third phrase. Let me pause for a second and take a look in chat.
That's just me letting everyone know that this will be this is being recorded, and we'll have it up on our YouTube channel shortly after
Okay.
this. So
Very
if you
good.
wanna follow along at another time. Like, what was he doing
Excellent.
again? We'll have it.
Thank you, Shannon. And
Yep.
again, feel free to jump in with a question, either verbally or in chat. And so with that, okay, so we have it trained. Now I need to be able to access this API. And so if I go over into my portal and I go under manage, all right. So for the sake of time, and this is a demo that I stepped through it in great detail in another presentation that's available on my YouTube channel. For the purpose of time, I just want to glance over the key features. But essentially, after I'm done setting everything up, all I need to do is to be able to take this URI and be able to make a call and essentially append my query here. And so having said that, let me step you through the code. So this is the UI. And again, don't judge. It's a very simplistic example. But the intent is that this would be on a PC in a car dealership, in a kiosk, where users can step up, enter in whatever they want done, and then it would respond back with the proper response. So here's the UI. What can I do for you? And they have a text box to enter in. They can click search, and then they get the results in the output window. Where the rubber meets the road. As soon as they click the search button, which is the search click, then we make a call to Lewis Parse. And what Lewis Parse will do is it will take whatever the user entered into the search box, and it will pass it to Lewis Parse. Lewis Parse then takes this as a query string, and then it appends it at the very end of the string, as we see here. Where did I get this entire URI? Again, this was from the portal, which is right here. After I set everything up, it gave me this URI that I can call, append my query to it, and then I will get the results in a JSON result set. So I have that in my code, so I can call it programmatically. So I make a call to the client, and it's an async call. I'm passing in the URI, and then once it comes back, then I'm checking to see that it was a successful call. Then I start to parse it, and basically it's going to give me a variety of intents that the user may want, with the topmost intent at the very top. So what I'm looking for is I need to parse it, and I'm looking for the highest intent or the top intent in that prediction. And these are the query details that are coming back. And so let's go ahead and run it. Oh, sorry, I forgot one more thing. So then after it comes back with the intent of what the user wants, I am now doing a switch statement, and I'm looking, does the user want to buy a car? Do they want to service the car? Or if nothing makes sense, I will say, please rephrase, I don't understand you. And I have the same thing in my default statement here. Okay. Now, in the case where they do want to buy a car, what I'm going to do is reply back and start the dialogue and say, we have X number of cars in stock. So with that, let's go ahead and run it. And there is my my kiosk interface. It says I want to buy a car. If I click search, Now it's going to go through the code. We're making a call to that URI. The status coming back is successful. Now it's going to read the string in the content message. It's going to deserialize that JSON that came back, and it's going to look at the topmost intent. And when we do a switch on it, we find out that it is by car. No surprise, right? And then we go through and then we display, we have X number of cars in stock. And we display that to the user. Okay, we say we have 3 cars in stock. So this is a very basic, simple phrase. I want to buy a car. Looking at how I built this, let me look under the intents. You'll notice I want to buy a car is listed on here, right? So it comes back that obviously it's a top scoring intent. But what if I was to go through the demo again and say, sell me a new ride? I'm going to go very slang on this. And you notice that phrase, sell me a new ride, does not exist in the 3 phrases that I trained it on. But when I click search, we'll step through the code again, a little quicker this time. And we'll see the intent that came back as by car. So I passed it in a phrase that it wasn't trained on, but because of the intelligence service, now that we are at the artificial intelligence level, it's looking at all the models that it used to get to that level. And it was able to take the phrase, sell me a new ride, and it was able to decipher that into, oh, this user wants to buy a car. Okay, even though I didn't train it on that exact phrase and didn't mention ride anywhere in any of the phrases, but it still was able to decipher that, just like a human being would. Make sense?
Scarily so.
Did you say barely?
Oh, I said scarily.
Fairly. Okay, what can I clarify for you?
Oh, no, scarily. Like, wow, that's really
Oh, okay.
accurate.
Excellent. Is there anything I need to clarify for anybody? So that's one of the AI features under language understanding. And as you saw, it involved a little bit of training in the sense that I had to give it some phrases. I identified which one was the entity or the noun. In this case, it's a car. I can also go a step further and to help be able to pick out what color of car the user is looking for, what trim edition, whether it's a GT or a convertible or an XL. I can pull all those out from the phrase or the utterance that the user is saying and be able to look that up in my database. Again, the key thing here is that I just kept it simple. And as you see, it processed things as a human being would. So it's a very powerful feature, in my opinion. So this is something that's already built, and we utilize the language and just expanded on it to identify which one is the entity in an utterance. Now, we can go a step further and utilize some additional speech services, which is another part of the Azure Cognitive Services. And that is over here. And so with speech services, it gives us the ability to do multiple things, specifically text-to-speech, speech-to-text, and then speech translation. So with text-to-speech, these are items that do not need a model to be trained, but rather it uses the model that Microsoft already trained it on. And so we can leverage that just by making an API call. And thank you, Royal, for joining. And you can catch this later on YouTube after it's posted. Well, thank you for joining. So if I want to utilize text-to-speech, what do I do? Like everything else in Azure utilizing cognitive services, I have to go into my Azure Portal. And I need to bring that up over here. And like everything else in Azure, it has to be a resource that's included in a resource group. And so there you see I have my speech services RG or resource group. Once we click on that. So a resource group is essentially a virtual container, if you will, of all the different resources that you're using in Azure. And this is useful for lumping things together for billing purposes and or identifying environments. So in my case, I have a speech services RG. And in here, I added in a speech services demo or a speech service. And to do that, I simply click create. And I go to the marketplace and then I specify speech services. Then I can utilize the service of my choice. And in this case, it was the Azure service. You click create. And then we'll prompt you what subscription plan do you want to utilize? What region do you want it to be in? Which data center essentially, give it a name, and then the pricing tier. So again, I will forego this step for the simple reason that I already have one created here. But the key thing is, once you have that created, like the Lewis service, we need to create that in order to be able to get this key and endpoint, because this is what ties into my Azure subscription and allows me to be able to utilize that service. So I will take this key and I'll take the endpoint and then I'll utilize that in my code. Because these need to be kept under lock and key, they're secretive. Basically, what I did in my code is I put them in my config file and then I'm accessing them here. Not that I don't trust you nice folks, but it's just a good security measure to keep that, on the side. So all I need is my subscription key and my region, which I get from over in my key and endpoints in my resource. Once I have that, this is in my text-to-speech and in my main method. So I'm going to go ahead and click Start. Put a breakpoint here. Whoops, wrong one started. Let's do that again. We want to do text-to-speech. We'll click Start. It'll get the subscription and the region from my config file, and then it will instantiate the speech config class using the subscription items that I defined here. Now, there are multiple ways that I can actually have this text spoken to me, and there's different voices that I can use with different accents. So here I'm going to use Jenny Neural, and she is going to be speaking English US. And as you see, there's a variety of different accents and cultures and male, female voices that I can utilize. So right now we want to see what Jenny sounds like. And then she's going to synthesize some text. And I'm going to enter into an infinite loop where it's going to prompt me for some text. And here's my command window. And some text is, I would love a large pizza. Did that audio come through?
Yes, but softly.
Yeah, I could barely hear it,
Yeah,
but I heard it.
barely.
Very good. All right, let's try another example. All right. So as you see, whatever text I enter in, it comes back with that voice. And if we try a different one, let's do Connor. I think that is an Irish accent. Come on, Connor. All right. So I assume you heard that as well. The point is, I can select from a variety of different voices and different cultures to choose from. And basically, we'll take whatever written text and then we'll convert that into a voice. Now, this, all I had to do was just simply set it up in the portal in Azure, utilize the endpoints, and then I'm off and running. It is utilizing AI. I didn't have to build any models. I didn't have to train anything. Everything was already pre-trained and done for me. I'm just now utilizing it. The same thing or vice versa with the speech to text. And we can turn that over and give that a shot. I would like a large pizza. And there you see it took whatever text I entered in or spoke, and it automatically translated into text. I'm interested in getting my oil changed. So the nice thing about this is now it's taking the spoken language and it's converting it to text. Now, if you tie this into with the Lewis service that we just covered a minute ago, now I actually can build an application that I can verbally speak to, and then it can give me the results back verbally, all using natural language understanding. And essentially, I'm having a dialogue with the application now. I no longer have to type in a strict sentence structure or speak in a very robotic structure, but rather I can talk as I normally would, and it would understand me. So in this case, where I said I'm interested in getting an oil change, if I submitted that to the Lewis application that I built, then it will come back with the intention that I want to have my car serviced. Or if I was to say something like, I want to buy a red Mustang. Then again, if I had that integrated with my Lewis application, then the application would know that I'm interested in a red Mustang, and it would query the database and tell me how many red Mustangs are in stock, or ask me the next question in the dialogue. Does that make sense? Where this can be integrated with the Lewis application?
Yes.
Okay, very good. And again, this is very simplistic in the sense that I don't have to build a model. All I did was incorporated the NuGet packages for the speech services. I utilized my subscription and my region and instantiated the speech config class. And then I was able to essentially listen to my user using the default microphone as stated here. And then it just rendered everything to the output. Okay. Now, another interesting feature is the speech translation. And for all three, I'm using the same subscription and region key, but I'm just going about the calls in a different way. I'm also using the default microphone, but now I am asking it to translate in different languages. So here it will, the recognition language, I want it to recognize that I'm speaking in English, US English to be specific. And then I want it to translate to Italian and to French. And so let me set this to speech translation. I would like to buy a new car. And voila, now I have an application that not only interacts with a human being where it can understand him or her, but now it can also do translation. Vice versa, I can set my language to Italian or French, and it can translate to English. So now my kiosk and my dealership can now interface with a variety of different languages with the users. Any questions about what we've done so far? So we talked about creating a machine learning model from scratch using the data in a file. Then we looked at AI features that required some training, like with Lewis. Then we looked at other AI features that required no training, but were able to use the services as is. So any questions about these items?
It's all good.
All
Thank
good.
you.
You're very welcome.
So
All
I have
right.
a question about the language. So you're doing a lot of this in C#. Are there other languages that you could use these libraries with?
Yeah, absolutely. Essentially, the core is that I need to be able to make an API call. So whatever language will allow me to make an API call asynchronously, I can use this with it. The only thing is, after I set it up in Azure, I need my subscription and my region. And then you see here that I'm making a async call. Where is it? Right there on line 26, where I'm awaiting the recognizer async. And so essentially it's an API call. Once I get the results back, I dissect it, and then I display the results on the screen. This is the output speech recognition result, and I just simply display the results here in this method. But this is the key item that I'm after. Once I make this call, I'm good. Does it answer your question, Shannon?
Yep, it sure does.
Excellent. Any other questions? All right. Last but not least is our good friend, ChatGPT. So now, if we look at our slide where we talked about the AI features, sorry, let's do this instead. So we built on the neural networks and deep learning. We were able to get to a machine learning where we actually had to do some training. And now we're at AI where there are some things that are already pre-trained. So, but like in the case of Lewis, we had to train it on specific language context for the application we were using, meaning we have to define what a car was. But if you take this and you take into consideration the internet is a vast amount of knowledge. So couldn't I use that as my model to train it on and be able to interact with it? And so that was the Open AI project that where ChatGPT was born from. And so they used essentially the internet as the training model. And if you think about it, anytime I need to do anything, whether I need to learn how to make a pizza, I need to fix a car, I need to be able to build a shed, anything that I need, I can find on the internet, right? And so by taking that vast amount of knowledge and using that for the model training, ChatGPT was born, where it's basically generative text that is born from the internet. So it generates these results out of the data that are collected online. And so let me pull up the project that I built for it. And so I did this in a Blazor application, and it's, again, very simplistic. But the key thing is with ChatGPT is you can ask it anything, and it will reply back with the results. So typically what I found is that this is to be 99.9% accurate, but there are some cases where that accuracy is less than expected. More specifically, like if you dive into some complex algorithms or complex questions, it'll come back with, didn't quite hit the nail on the head, but it certainly came very close. And so let me share my solution with you. So this is essentially a Blazor application. And if you're not familiar with Blazor, it's utilizing C# and some Razor pages. And all I had to do was essentially bring in the NuGet package for AI, OpenAI rather. And there you see the OpenAI NuGet package incorporated. Then I went over into my pages and I created a OpenAI Razor page. And within here, I'm essentially referencing some things within the library. And then I'm prompting the user for some text. And then I'm displaying the generated results on the bottom. Now, just like I did with Azure, everything had to revolve around a key. So we have an open API key that I'm utilizing, that I'm retrieving from my JSON file, where I'm storing all my settings. So that key is stored there. To get this key, simply go to openai.com and be able to register as a new user. And then from there, you can get the key and you're off and running. And so once I utilize this key, then again, I'm able to make an API call. And then once I get the results back, then I parse it out. As we see here, we make an async call, and then we display the results into the text field. So what does that input look like? Let's go ahead and run this. We'll give it a second to spin up. All right, so that's the default page. Let me go to the OpenAI and enter a prompt. What are some of the things that I would want to ask it? As you might have guessed, I am a big pizza lover. And so we're going to go with that. How to make a pizza, generate the texts. And there it comes back with the results of how I should go about making my pizza. So very simple, very straightforward. No training involved because it's already been pre-trained on essentially everything that's available online. So I can ask it a variety of different questions. I can say, how can I make my resume stand out? And I'll spell stand out correctly. And there's the results. So again, the code for this just utilizing the key that I'm retrieving from my config file here. And then I make the open API call. And this is utilizing the NuGet package that I imported. After that, after I make the async call here, then I just simply display the results in the response box. Okay. Any questions? All right, it's 8:01 right now, so we've been going for an hour 15. If you'd like, I can show you AI with T-SQL. We'll just need a little bit of a break, and then we can continue on. Or would you prefer to do a Q&A and call it a night? What are your thoughts? Shannon, everyone?
Well, how long would the demo for T-SQL go?
So the full demo would take about an hour. I could do an abbreviated one in less time.
Yeah,
I'm
that.
okay with Q&A.
Oh,
I'm
yeah, we
sorry?
got a message. Yeah, so it looks like Q&A, but I would love for you to do another meetup with that.
Would be happy to.
That
Absolutely.
would be
Yeah, I agree.
awesome.
Sure.
Yeah, that would be awesome.
Okay.
Yeah, that way you could take the full, hour and really show us
Sure.
everything. That
Yeah.
would be
It would
great.
be my pleasure to.
All right.
Um,
Well, we'll hook it up.
Excellent. All right. So with that, let's get into Q&A. What questions can I answer for you?
So this last demo, you got the key for OpenAI. Did you, I might have missed it, but did you have to have a paid version, or do you get that with some free tier?
There is a free tier. Well, you just
Okay.
simply have to register with your email, and then you're off and running.
So a lot of this, I think, I haven't looked into even the Azure related stuff, but they have a lot of free tiers of things. Do they have free tiers of like AI, where you can make like, 1,000 calls before they start charging you or anything like that?
Yeah, exactly. So looking at my portal, let's see if I go over into home and speech services demo. So there's the pricing tier, and essentially there's a free tier for everything that I showed here.
Right.
Obviously you have some limitations, but for development purposes, it's more than adequate.
Oh, great news. So you can get in there, you can do some of these things yourself, learn, fail, repeat, and it's not going to cost a whole lot of money.
Exactly.
And I would assume that you probably think AI skills are going to be pretty valuable in the next, say, 10 years. Like someone could make a solid career out of doing that.
Quite honestly, I think they're valuable now. And the reason being, so if you look at the first demo that we created with the ML.net, what we did was we took some existing data and all we did was label it, right? Where we said either it's a positive comment or a negative comment. There's nothing stopping us from doing that in our current organization. Whether if you have a social media profile, you can download all the comments and then label them and then train it. And once you train it, then it can go through and identify future comments, whether they're negative or positive. And if they're negative, obviously you want to escalate it quickly to customer service and have people take care of it. Another thing you could do, like we talked about, one of the things you could do with ML.net is forecasting. We all have previous sales data. We can take that and use that for forecasting in the future. So it's something that we can use in the here and the now for almost nothing, really. ML.net is free to download and use, and you're using your existing data. So what's stopping you from doing it now?
Oh, nothing. The point I was trying to make is that it's a valuable skill. Like it's something that you're not going to be putting time into, and then, that was fun. I'm just trying to think of like some JavaScript framework I learned once, and then by the time I had gotten really good at it, nobody was using it anymore,
Yeah, I hear you.
I think the AI tools, what's great is that you can get started, you can learn these skills, you can start now, and the skill will continue to be valuable for you in the foreseeable future.
Yeah, absolutely agreed. Yes. And I hope I didn't come across too aggressive. What I was trying to get at was to say that almost every organization already has existing data.
Yeah.
There's nothing stopping us from actually utilizing that and making something of it instead of just having data sit on the disk, right?
And as a data professional, I will tell you that organizations are just drowning in data. They do need some help sorting it out. So AI can help in that respect. Even if you're not thinking, oh, I don't know about AI, even if you're just a data professional, being able to hand over some data sets with like a classification or developing an application where someone can ask a question in human language instead of trying to read a graph that somebody else made.
Yeah,
Would be extremely valuable to an organization.
absolutely. Not only that, but as we had seen with the other services, with the translation, you can essentially have recognize almost any language. You can have it as a drop-down box where if all I can speak is Italian, I would select Italian and I could speak to it and it would translate it into English. And then I could submit that into the Lewis service. And then it would reply back to the application with what my intent is, whether it's buying a car or servicing the car or what have you. Make sense?
Yeah. So what does everyone think about the content? Was this valuable for you? You can type in the chat or unmute yourself and let us know. Yep, Adam, you raised your hand. Go ahead.
Yes, thank you. Thank you for this wonderful, the journey that you took us on.
Thank you.
Yeah, a few questions. One, you started off by saying something about you drank the Microsoft Kool-Aid. What other flavors of Kool-Aids are there out there? And what is it that you wish that the other Kool-Aids would have in yours, in the Microsoft one? That is one, and I have like a gazillion ones, but I don't want to dominate here. So I'll take your response.
Well, first of all, any questions you may have after this doesn't mean that the dialogue stops at the end of this presentation. I'll make my email available. Feel free to reach out to me. I'd be happy to help. And I'd also be happy to help you get on the right foot with your next AI project. Having said that, as far as the different flavors of punch, there are a lot of other frameworks out there for machine learning. So predominantly TensorFlow and Onyx are two of the big ones that come to mind. Python also has a slew of libraries that are available to be accessed within Python scripts for doing a lot of the AI and machine learning tasks. I personally, what I like about the Microsoft platform as a whole, not just with AI, but in general, number one, you have a large community around the Microsoft development teams and efforts. So a lot of documentation, you can get questions answered easily. Things are very easy to understand and very intuitive. And so that's the one thing that kind of keeps me within that scope of frameworks and tools. But they are opening and spreading their horizons more. So they're incorporating things like Python within SQL Server. They're incorporating the ability to utilize Onyx and TensorFlow frameworks within Visual Studio. So does that answer your question? There's, like I said, a lot of frameworks out there, but I find that with Visual Studio, it gives you a very rich experience in the development and debugging, but you can also utilize it with other frameworks as well.
No, this is very helpful, so thank you very much. And
Sure.
I'll just throw a follow-up that I think Shannon started with, which is, how do you see the projection? I'm sorry if it wasn't Shannon that asked that question, but I don't know if you heard me in the beginning. I'm interested in the federal government contracting space, and that's why I'm here to hopefully recruit you all so that you can, drink my Kool-Aid. But what do you think of that industry and that sector?
So can you clarify your question a little bit more? How do I see AI fitting in the federal space as far as applications and so forth?
Yeah, what is the potential? What is there? Because there's a lot of points where the government asks, what can we do with this stuff? And they are looking for ideas to make sure that they're, staying current and on the cutting edge.
So some of the services that I didn't mention were the vision service, and let me pull that up real quick. So with the Vision service, again, offered within the Azure Cognitive Services, it gives you the ability to do all these items where you can identify an object, identify a specific face. You can also analyze the content in a specific image. So for example, I can walk into a store and say, sell me one of these things, whatever these things are called. This is a mouse that I'm holding up, obviously, right? But if I don't know what it's called, I can hold it up to a camera, it will take a picture, and using that service, it will identify this as a mouse. And then it will say, you know, we have three different kinds in stock. I can also use it for doing OCR and analyzing the handwritten notes in an image and be able to decipher that. Same thing with or similar with video indexing or identifying people in a specific image. So that's all within the Vision service. So in addition, I can also use there's libraries out there that are available for identifying the license plates as cars are coming in and out of a parking lot. So whether it's government or the private sector, you can utilize a variety of these applications in many different ways that would be very beneficial. You know, I like, for example, scanning business cards or forms, and you extract certain information out of it, and then you upload it into a database or make an API call with it. I can identify the face or images. And just to expand on that a little bit more, so with face detection, basically, I would submit an image, and then it would respond with a JSON result set back. And in this case, I see that it's showing roughly the 23-year-old female, and it's giving me the coordinates of where her face is located in the image. And it's giving me some additional metadata on the image, the width and the height. Likewise, I can use it for object detection, where, again, it's responding back in JSON, and it's identifying different objects. So here, it's identifying a kitchen appliance in this section and in this section. And you'll see that it's giving me the rectangle coordinates of where that appliance is in the image. It identifies a computer keyboard, it identified a person, et cetera, et cetera. So I can use all this for, again, expediting things from just basically dissecting an image instead of just taking a picture and hoping someone will see it later. Another project that a friend of mine worked on was basically for an electrical supply house where they had a variety of different electrical equipment and they didn't know what was what. And they needed a quick way to categorize that and classify that so they can take inventory. And you can have a junior guy saying, we have 2 of these units in stock, whatever this thing is called, right? And with object detection, it detected that this was a mouse or a transformer or a keyboard.
But isn't that part is intensive on the training side? 2 years ago, I was part of this where I was given the opportunity to train just to see how it works. And it was, it took some time. It was fast, don't take me wrong, but it needed some work, especially on the visual side.
Right.
Is
So
that
some things
still the situation, or did they move on from that and there's something that you can download that would help?
Yes and no. So there are some things that need training on. So for example, a mouse, I'm sure you can find a variety of images that you can train it on the internet, right? But if you have a specialty part, let's say an electrical transformer or a key component, not only do you need to take pictures of that part, but you also need to take it from different angles and if it comes in different sizes or different colors, then you need to train it on all those different varieties. But on the other side of the token, there are some things that don't require training, like language, for example, right? I can submit a request to say, I want an oil change, and it can translate that into French or Italian, right? Or can just translate it go from speech to text. So some things need training, some things do not.
Okay. Thank you very much.
Sure. Very welcome.
We have some chat questions in the chat. So
Okay.
the first one is, how do you train OpenAI or another large language model with your information?
So depending on the model that you're using and the SDKs that are available for it, you may be able to train it on your data. Others, for example, and again, going back to the Microsoft platform. So with the speech services, although it can take text and translate it into speech, let's say that I wanted to recognize a specific accent. Let's say, and if I spoke with a thick Italian accent or a Middle Eastern accent, then it may not be able to pick it up as plain English, but rather I can fine tune it to my specific accent. And likewise, on the other end, where when it goes to speak, I can modify the accent on that end as well. So it varies on the package that you're using and the SDKs that it exposes, whether it allows you to train them or not. I can't say as a blanket that X can be trained and Y cannot. It just depends on each individual package and the scenario that you're after. Again, Dean, feel free to reach out to me afterwards and we can discuss it in more detail. I'd be happy to discuss it with you. Nancy, can you do forecasting of stocks in the stock market? That's also accurate. Does it really need to be accurate, Nancy? Can't you just take some chances? But all joking aside, you can do that. However, keep in mind, think of the example that I mentioned with the home sales. All right. The very basic example for home sales was based on square footage. In reality, it's based on a lot of factors. The number of bedrooms, the amenities, the zip code that it's in, et cetera, et cetera. The list can go on and on. For stocks, it's even broader than that because stocks can be affected by what? Political climates, can be affected by actual weather climates, can be affected by other businesses within that vertical and the competition. So you would have to take all those as features because those are input values that will dictate whether the price of the stock will rise or fall. And there are organizations that have built forecasting applications for doing this, and they have been pretty accurate. But again, it's all in how well you train it. Think of it this way. If I was to give you, provide a 25-year-old college graduate and say, train him on being a great stock trader, what are the different things that you'd have to train him on to do well and be able to be accurate? There's a lot to train on, right? A lot of factors, and it's going to take some previous historical data to train him on that. So it's the same thing with the application as well. Does that answer your question, Nancy?
Yes, she said
Excellent.
yes.
Very good. Next one is Courtney. How can I start to obtain the AI skill set? So there's a variety of ways you can go about it. I'll make a set of references available. Microsoft has some great write-ups and tutorials on how to do that in a variety of different ways. Either ML.net, Azure Cognitive Services, using AI with T-SQL in SQL Server Management Studio. You can also look at tutorials in Python for doing machine learning. The key thing is, and I hope I got this point across, the differentiation between neural networks all the way up to AI and how things are built on top of each other. So once you have that basic concept, there's a variety of different frameworks and tools out there in the marketplace. And not to mention lots of tutorials. Also, if you reach out to me, I'd be happy to point you into some specific direction with tutorials or even give you a hand with it.
Thank you very much.
You're very welcome. Rebecca, for the field of data science and data analytics, is it worthwhile to start out by studying how any of these programs, algorithms work under the hood, the logic, statistics, et cetera, behind them? Or is it higher yield to simply learn how to simply use as many tools, frameworks, libraries as possible? I would say probably the latter is going to be more beneficial because there's a lot of high-end scientists that are working on these algorithms under the hood. However, if you're looking for a specific scenario and you're looking to fine-tune it, that's where you would need some more mathematical skill set. But more and more frameworks are coming out where it's abstracting that heavy math layer aside and making things easier for you, where you just have to make an API call and everything is done for you. So I would opt for the latter. And okay, so it looks like we were on the same wavelength, Rebecca. That's good. All right. Again, folks, feel free to come off of mute. I would be happy to answer any additional questions for you.
I wanted to mention that Microsoft has a machine learning challenge going on right now, and so you can go through their tutorials for free. And sometimes in some of those tutorials, they'll spin up little sandboxes so that you can do like a little mini project during your learning. And to get started with that, you can go to learn.microsoft.com. And the challenge goes, I mean, these resources are available to you after the challenge, but the challenge goes until August 14th, I think. Yes. And if you finish one of the pathways by August 14th, then you get, a cool badge to add to your LinkedIn profile or your website or whatever other vanity place you want to put it. So
it's all about the cool badge.
it is. Gamification works.
Absolutely.
I happen to also be going through it. So I'm doing there's 4 challenges that you can go through. I'm doing the machine learning challenge, but so if you pick one and you're interested in chatting about it, let us know. I can set up a group where we can get
Yeah,
together.
they have
and
some.
help each other
Sorry.
out. Yeah, you're good.
No, they have some great documentation and some great tutorials. Also, I found some links on IBM that were very helpful in explaining the basic concepts. So that was useful as well. But what you see on the screen is essentially my link tree. So a variety of links, whether it's email, LinkedIn, YouTube, everything's available through that link tree link. So feel free to reach out to me there. In addition, if you're interested in having a no obligation assessment for how you can make AI feasible in your organization, feel free to reach out to me. My email, snasr@nistechnologies.com. You can also find me on Twitter, and then I blog for various tech events and other AI-related articles on my blog. And I also invite you to connect with me on LinkedIn. And so with that, I thank you all for attending. And again, just because the presentation's over doesn't mean the dialogue stops here. I would love to hear from you. Any questions that I can answer for you, any tutorials you need help with. I thrive on helping people and would look forward to helping you as well.
Thank you.
Thank you so much,
Thank
Sam.
you.
It was
so much.
great. I
Mhm.
love
Thank you, everyone.
how you put the perspective of neural networks, deep learning, machine learning, and then finally AI, because people are like AI, and then they're like, tell me more about AI, and then they're like, there's this thing called machine learning, and it's like, wait a minute, I want to know about AI, not machine learning. So putting it into perspective, I just wanted to comment on that was a really good visual, and I think
Thank you.
that does put
Yeah.
things in
It was like alphabet soup. And, when I
Yeah.
first started out, I'm like, well, what's what? And how do they differ from each other? And, what should I focus on? And so that, even though it was an intro talk, I wanted to touch on the building blocks, because once you know the building blocks, then the rest is easy to put together.
All right. Well, thanks everyone for coming. Thank you, Sam, for presenting.
Thank
I
you.
look forward to the next time.
Likewise. Thank you.
Thank you.
Thank you so much.
Thank you.
Thank you.
Bye, everyone.
All right. Good night, everyone.
Bye.
Bye.